Hey everyone, welcome back. Mr. Skelton here, getting ready to talk to you today about classifying and measuring angles. So that's the topic for today. The two learning targets. The first one is to be able to understand the angle addition postulate and to know how adjacent angles are related. The angle addition postulate, very similar to what we did the other day with segment addition postulate. So you'll see some similarities there. I'm going to jump right into some work here. Adjacent angles. If you want to circle the word adjacent, if just defining the word adjacent, the easiest way to do it in geometry is just to say next to. Okay. Adjacent angles also, if you want to get specific, they share a common ray. And I'll show you some examples of that as we go when we start to talk about the different types of angles. Okay. The second learning target for today is to be able to classify angles as acute, right, obtuse, or straight in different situations. This should be review for you, but it's always a good, helpful reminder to go over those big foundations here in geometry in terms of laying the foundation and getting a good solid base underneath you as we get started out in this school year. All right, first thing, angle. Here's the definition. Angle is formed by two rays with the same endpoint, and the rays are the sides of the angle, and the endpoint is what we call the vertex. So in terms of visuals, you can see this angle right here, and this angle has a vertex of B. Okay, so B would be your vertex. The two rays would be BA and BC. Now, naming an angle, you can do this in different ways. I'm going to go through the different types of ways to name angles. So the first one here, if you have a vertex present, and it's the vertex for this angle and only this angle, you can call this angle B. The symbol right in front, it kind of looks like a greater than or less than symbol, but that's our symbol for angle. So if you're talking about an angle, you need to use specific symbols. The other way to name an angle is using the three letters. When you do this, you have to use the vertex as the middle letter. So for example, I can call this angle here angle ABC. Excuse me. The third way I can name this angle is just going the opposite direction and starting at C and calling it CBA. So angle CBA. And if you notice, in both of these, if you look at the middle letter, it's the vertex, and that always has to be the case. Okay. Right here is just getting a little bit more specific and naming the rays. Good review for us, so we can call that BA with our ray symbol over the top, and BC with our symbol over the top. Our vertex, we already said, was point B. Okay. In terms of defining angles, or defining the four types of angles, you have acute, and acute means that X, and I'm going to say that, I'm just going to call this angle X right there. That angle X has to be obviously greater than 0, but it has to be less than 90. Okay, for an acute angle. So if you kind of cover this up, you can kind of see that X has to be smaller than 90. All right, move this up for you a little bit here so you can see. Obtuse. Obtuse is an angle, again I'll call it X, call this angle X here, that has to be larger than 90. Okay, so your angle is larger than 90 and has to be smaller than 180. That's an obtuse angle. Your right angle, a lot of you are familiar with the right angle. That's just X, I'll call this X again. And that's just straight up equal to 90 degrees. Another way of describing a right angle is that these lines, or these rays, are perpendicular to each other. Perpendicular lines, that should be a familiar term to you as well. And then the last one's a straight angle, and this is something, these two right here, you're going to see a lot in geometry in terms of the angle addition postulate. It's just going to show up here down the road. But a straight angle, if I called this X, is equal to 180 degrees. Any straight line in geometry, when we're talking about measuring something, is always 180 degrees. Okay? Real quick, I wanted to talk about adjacent angles. We mentioned that real briefly at the top and what adjacent angles look like. I'm going to give you an example with the right angle right here. So I'm just going to draw in a ray. Okay. And for the sake of description here, I'm going to actually label this A. I'm going to call this B. And I'm going to call this C out here. Okay. And I know I called this 90-degree angle X, so I'm going to kind of scribble this out now that you know that's 90. And I'm going to give these two angles, I'm just going to call it angle 1 and angle 2. So angle 1 and angle 2 would be an example of adjacent angles. I'm actually going to put a fourth point out here and call it D. So you could say that angle 1 and angle 2 are adjacent. And the reason you know that is because they share a common ray. Here's BD. Angle 1 and angle 2 both share ray BD. So that would be considered adjacent angles. They're next to each other. All right. So down here towards the bottom, we're going to apply some of those classifications with a problem. This is something you'll see as you move forward. Maybe tough to see, but this is angle of 70 degrees right here, and this one is 90 degrees, and you can see the 90-degree box right there. So the directions say, find the angle measure of each angle below, and then classify the type of angle. Now, again, the main focus for you, especially if you're looking at these four, should be the middle letter, because that's going to always be the vertex. So what I always do in the beginning when I'm teaching this to students is, like for example, number 1, it says ABC. So I just put my pen or pencil right at A. I know I have to go to B next, and then I have to go to C. So if you just trace that, A, B, C, the angle is in between those, which would be 70 degrees. Now, based on what we did up top, 70 degrees, how would you classify that? That would be acute. Smaller than 90, greater than 0. CBD, so start at C, then go to B, and then go to D. Now, in order to do this, you know that ABD is a straight line. You can see it right here. And we know that straight lines are 180 degrees. So if part of that is 70, you just do some basic subtraction. 180 subtract 70 gives you 110 degrees. So the measure of angle CBD has to be 110 degrees. And that would be an example of an obtuse angle. Okay? The measure of CFG, here's C, all the way down to F, which is in the middle, and then G. Now, very similar to the last problem, look at this straight line right here. This is a straight line going all the way across. You already know that this is 90, so then the angle that's adjacent to it would be 90 degrees as well, because 90 plus 90 has to make 180 degrees. So going back, CFG would be 90 degrees, and that's an example of a right angle. Last but not least, number 4, CFH. So starting at C, going all the way down to F, and then going down to H. So basically, we just went in a straight line all the way down, and we know that straight angles are always equal to 180 degrees. And that would be a straight. Okay. We're going to flip it over to the back side of notes here and talk more specifically about the angle addition postulate. And to be honest with you, we've already done a little bit of it already in the problems that we just did. So the angle addition postulate, just like the segment addition postulate, is basically when you add two adjacent angles together, you can get the entire angle. Okay? So right here, it says if P is in the interior of angle, it should be an angle symbol right there, of RST, then we know this. RSP, so angle RSP, plus, what's its adjacent angle? And you can name it a couple different ways. I'll go angle PST, that equals the entire angle, RST. A good reminder here, when you're naming angles, you're always going to use 3 letters unless you have the vertex. Okay, so this is a unique situation as well. I'll have some students who think that they can call this angle RST, that they can just call it angle S. And it's a little confusing for students at first, but you couldn't call this entire angle right here S, because S is actually the vertex for both this smaller angle here and the one right below it. So when you have more than one angle sharing the same vertex, you have to use 3 letters. If I just had this angle here and I called it A, B, and C, I can call this angle that's created right here, I can call that angle B, because it's just one angle. But as soon as I put another ray right down the middle and put a D here, I can't call that just angle B, because now you have 2 angles and I don't know which one you're talking about. Okay? Alright, moving forward here. Let's apply this to some problems. On the left side it says find the measure of the angle below by using the angle addition postulate. So it asks you to find ABC. Again, always look at the middle letter. So you're going to start at A, you're going to go to B, and then finish at C. So A, B, C. So we want this entire angle right here. Well, since we know this is 38 and this is 32, we just add those 2 angles together, and that should give you 70. Okay. Now below it, number 2 is a little bit tougher of a question, and I know I'll try to zoom in just a touch here for you. Keep this in the screen so you can still see it. This says 11x minus 12 here, and this is a 2x plus 10. Okay, so if you need to darken that in a little bit, I apologize, that should be a little bit darker for you. Alright, so here's what we know. All we have is that visual, and all we have are those algebraic expressions. These are the kind of questions you're going to see on a quiz or a test. I want you to look at angle DEF. Just trace it with your finger real quick, or your pen. DEF. What do you know about DEF? You should be saying to yourself right now that that's a straight angle, it's a straight line, and you would be correct. Well, what did we learn on the front page about straight angles? They're always equal to 180 degrees. That's very helpful in this problem. Okay? Here's why. I know that this angle, DEC, plus angle CEF, both of these together have to make 180 degrees. That's the angle addition postulate. This angle, this obtuse angle, plus this acute angle makes the entire straight line. So that's how we set it up. 11x minus 12 plus 2x plus 10 is equal to 180 degrees. You're going to solve that for x. Put your like terms together. That's 13x. Negative 12 and 10 make a negative 2. And that's going to give me 180. Okay. Then I'm going to add 2 to both sides. So go ahead and add 2 to both sides. And you should get 13x equals 182. And then we obviously need to take our 182 and divide that by 13 on both sides. And you should get x equaling 14. Okay? Any questions on that one? If you do, we can get that figured out tomorrow when you come into class. But you should be good to go there. Now, sometimes they're going to ask you to plug things back in. So right here you can see angle 2. It says find DEC. Well, DEC is this angle right here. So now that you know x is 14, we have to plug that 14 back in for this x. So it's going to be 11 times 14, and then subtract 12. And that should give you 142. Now there's a couple different ways you can find CEF. Again, CEF would be this angle right here. You can plug x in for the x in the expression, or if you know this is 142, all you need to do is take 180 and subtract that 142 from it, and that should give you 38 degrees. Okay. The one on the right, you can go ahead and hit pause real quick if you want and give that a try. It's a very similar problem to the one we just did. And I'll check back with you here in a second. All right, DEF. Measure of DEF, again, is a straight line, and you can see the 109 and the 71. If you add those together, it should make 180, so that's going to be 180 right there. Now, number 2 is a little bit different. It says MRT is 133. Now, I want to clarify something. I should have said this earlier. You see this little m right here? A lowercase m in front of this angle symbol means measure. So you would interpret this as the measure of angle MRT, with R being the vertex or the middle of the angle. Okay? So if you look down here, MRT, that whole thing is 133. So I know that this angle here, I'll put a little dot, plus this angle here, which gets a second dot. If I add those two together, that has to make 133. So that's 2g minus 2, which is the expression right here, plus 4g minus 9, which is this angle right here. That has to be equal to 133. All right, we'll solve this real quick. Put your like terms together. 2g, 4g is 6g. Negative 2 and negative 9 is negative 11, equals 133. Then you're going to add 11 to both sides. So go ahead and do that. So 6g is 144, and 144 divided by 6 should give you 24. Now again, make sure you double check what the question is asking you. You can see right here it asks you to find x, and then it asks you to find two angles. So I'm going to put my 24 back in here. Again, little m stands for measure of angle MRN. So MRN, just trace it, start at M, go to R, and go to N. So that's this angle right here. I need to plug that 24 back in for G. That says 2 times G. So 2 times 24 is 48, and 48 minus 2 should be 46 degrees. Now again, there's two different ways to find NRT. NRT is this angle. Now you know the entire thing is 133. The entire angle is 133. So if you just subtract 46 from that, you should be able to get the answer without having to use substitution to plug it back in for G. So I'm going to do that, 133, and I'm going to subtract 46 from it, and that should leave me with 87. And you can double check it by plugging 24 in for G. 4 times 24 minus 9 should give you 87. Okay? So that's a quick tutorial on the angle addition postulate, as well as classifying some angles. So when you get into class, if you have any questions over these examples or how to label things or name things, and I'm sure you're going to have some questions on the angles, we can go over that in class and also with your homework. So watch it again if you need to. Come to class with questions if you had any over these notes, and I'll be happy to explain them when I see you tomorrow. Okay? All right, have a good one. We'll see you in class tomorrow.